Good morning, class. We are looking at college algebra practice test number 4, module 4, covering chapter 7 and 8. Here's chapter 8, analytic, geometry, and this is the second part. Reminding you of before taking the exam, you are supposed to pledge on your honor that you will not receive unauthorized assistance. I can't emphasize this enough. What's a parabola? A parabola is a set of points in the plane or curve such that every point on the curve is equidistant from a point called a focus and a straight line called the directrix. So if you look at this parabola, and this is the focus, and this is the line directrix, DFP, that means the focus and some point P and the distance from the same point to the directrix. If you drop a perpendicular, the distance from here to the focus and to the directrix. So from here, so this opens up. If it opens to the right, from here, drop a perpendicular to the directrix and connect it to the focus. They must be identical. Now, from the focus, if we draw a line segment parallel to the directrix, where it cuts the parabola at this point and this point, this distance is called latus rectum. And the distance from the vertex to the focus is called the focal distance. Needless to say, according to this definition, the distance from here to the focus and the distance from here to the directrix must be the same. And the directrix is perpendicular to the axis of symmetry. Now, reminding you of the formulas we've seen in algebra, y equals ax squared plus bx plus c, or a times x minus h quantity squared plus k. This is the vertex format. It opens up if a is positive and down if a is negative. So when x has the exponent 2 and y is of degree 1, it opens up or down. When x is of degree 1, but y is of degree 2, it opens sideways. So x equals ay squared plus by plus c, or a times y minus k quantity squared plus h. This would be this type. So the bottom is this type, the top two would be this type, up or down. Now, if we go with this concept of a directrix and focal distance, then we can write y squared equals 4px or minus 4px. If you look at this, in many texts, they use y equals 4ax or minus 4ax. I rather go with p. Here's the reason. P is the focal distance, this distance that was mentioned, this distance, or this distance. In some books, they call that distance A. The problem is it can be mixed up with this A that we have learned in algebra. Therefore, I'm going to stick with P, but pay attention with the way various texts mention that. So when I go with that, x squared is 4py, x squared is minus 4py, the relationship between P and A, this A, and this P representing this focal distance is that P is 1 over 4A or A is 1 over 4P. It makes it very easy to handle. And so it doesn't have to open up, down, right, or left. These are various formulas. It can open anyways, but it is important to know the axis of symmetry and the directrix, they are perpendicular. And any point from the parabola connected to the focus, drop a perpendicular to the directrix, those distances must be the same according to the definition. Latus rectum, as it was mentioned, the latus rectum of a conic section is the chord line segment through a focus parallel to the conic section directrix, and it's equal to 4p. It's easy to see that if you look at this distance is p, this distance is p, they're going to call it a. Therefore, this distance is 2a, and I'm going to call it 2p. Okay. And so if this distance 2a, so is this one. If you continue, because that means half of it, right? If you continue, makes it 4a, but as I said, I'm going to go with 4p. All right. So that is the distance we are referring to. Now, y squared equals 4px. If you have it centered at h and k, then y minus k squared is 4p times x minus h, or x equals a times y minus k quantity squared plus h. And as I mentioned, the relationship between the two is such that a equals 1 over 4p. So having said that, let's have a warm-up example from algebra. Given the function f of x equals x squared minus 6x plus 8, and this is the vertex format. If it's not, you can put it in vertex format, or you can calculate the vertex as x equals minus b over 2a. So x minus 3 quantity squared minus 1. Determine which way the graph opens, find the vertex, axis of symmetry, draw the graph, find the domain and range. So we're going to go with the algebra and the basic concept that we have seen before first, and then we're going to take it from there. All right. So first and foremost, A is 1 and it opens up. And again, I want to mention if you look at this one, the vertex has the equation x equals minus b over 2a. In other words, if this wasn't given, this is given. So we know the vertex, okay, located at 3, negative 1. We are looking at this formula. Again, reminding everyone of what we have seen. And so A is 1, positive opens up. The vertex at 3 comma negative 1. And because you have the vertex x equals 3 is the axis of symmetry. Those are information we remember from algebra. So the vertex is at 3, negative 1, as it was mentioned. Now, to find the y-intercept, we set x equal to 0, and actually from here you can see the answer is 8, so 0, 8. To find the x-intercept, we set the y or f of x equal to 0. That means it's easier to set this one equal to 0, and that's an easy factoring. You want two numbers, the product is 8. The sum is negative 6, so minus 2 and 4. So the answers are positive 2, positive 4, which means 2, 0, 4, 0. Get to the habit of writing them in pairs. Let's write a summary table. So we have, this is the y-intercept 0, 8. This is the x-intercept 2, 0. This is the vertex 3 comma negative 1. And this is another x-intercept 4, 0. I'm going to discuss this in a moment. For now, let's just draw this and notice that's the vertex, the y-intercept 0, 8. The x-intercepts at 2, 0, 4, 0. And notice by symmetry, if we have this point, which is 3 units from the axis of symmetry, if you go 3 units, you get to this point, which must have the same y coordinate and the same distance from the vertex, the axis of symmetry. So this is 3 units. This adds another 3 units, gives us 6 comma 8. And that's a graph, very straightforward. From the graph, Any parabola opens up or down makes no difference. The domain is our real numbers, minus infinity to negative infinity, minus infinity to positive infinity. But the range depends on the location of this one. If it opens up, starts from the y coordinate of the vertex to infinity. If it opens down from negative infinity to this point. So from -1 to infinity, is -1 included? Absolutely. Is infinity included? No. Infinity and negative infinity are concepts. We always go with parentheses. This is what we did in algebra. And you can do this and then convert it to the format that we learned here. But what I want to do, I want to show you the same question and add a few more things. So same question, we're going to continue. And the same graph, vertex, axis of symmetry, the formula, the vertex opens up, intercepts every piece of information from the previous page. Now we also want to find the focus, directrix, and 2 points that define the lattice rectum, LR. So remember what I said. The relationship, this is, if you draw just the way it is, and I'm going to erase my work. Just the way it is, we should know, therefore, and it may not be too scale. Somewhere here is the directrix, because they have to make a 90-degree angle. And somewhere here, and on purpose, I'm going to put it in completely a wrong place. Somewhere here is the focus. Definitely it's not there. I just want to make a point. What you should recognize, because it opens up, the directrix is below it. This distance of what? Focal distance P. So from the vertex, you go down by that much. And the focus is above it. So from the vertex, you go up by a focal distance. So I want you to understand the concept. I'm going to erase my work in a moment. But before I do that, I want to go back to this that I mentioned, the relationship between P and A, the focal distance and A. And remember, for us, A is 1. Go back here. A is 1. Therefore, P, which is 1 over 4A, is 1 over 4. Let me erase my work. So we know a location for each one. We just don't know the number, but I just mentioned what happens here. So the focus would be having the same coordinates as the vertex. Let's go back to the vertex. As far as the x coordinate is going to be the same. As far as the y coordinates is, we are going to add the focal distance to it. Okay, let me now erase my work. So we have the same x coordinate, we have the same y coordinate plus p, which is 1/4. So it becomes 3 and negative 3/4. That's the location. Again, this is hard to register, but you know what I mean. The directrix, as I mentioned, is below it. And the formula for the, let me just write this. For the axis of symmetry, x equals 3. For the directrix, y equals something. And where you want to write y, you look at the y coordinate of the vertex. Here's the vertex, the y coordinate of the vertex, and you go down by focal distance, subtract from it. So y equals the y coordinate of the vertex minus p, which is 1/4, and it gives you y equals minus 5/4, and that's the line. So I hope everybody understands how we arrive at each case. So if we want to go with the format in this case, remember y is x minus 3 quantity squared. We say x minus 3 squared is y plus 1. That's how we write that now in this format. That's the format we are referring to. All right. What is lattice rectum? So from the focus, if you draw the chord or the line segment where it crosses the graph of the parabola, this point and this point, this distance is lattice rectum distance. So what are the points? Let's see what color we want to go with. Let's go with red. These are the points that we can find and then find the distance between the two as the lattice rectum. And we know lattice rectum is just 4 times p. So we know the distance is 4 times p. We are going to use that methodology as well in a moment. But for now, one way is if you look at this focus as the following coordinates. So these 2 points have the same y coordinate. So I don't know the coordinates for this point. I don't know the coordinates for this point, but both of them must have y equals negative 3/4. So y is negative 3/4. What is x? How do you find it? Put it back into the equation of a parabola. This equation or this equation. The y coordinate is negative 3/4, everybody. How do you know that? Just by the nature of the lattice rectum. And evaluate. So I'm going to leave it for you to verify that. And therefore, the end points are 5 halves negative 3/4 and 7 halves negative 3/4. This is one way to find those points. Is there an easier way? There is another method. Here's the second method, everybody. We know the focal distance. We know the focus is located at 3 comma negative 3/4. We know the x coordinate for the focus is 3. So we are going to add and subtract 2p. Remember, p is 1/4. And we know this distance is 2p, everybody. So 2 times p. Add and subtract. So add plus minus 2p, which means 2 times 1/4 is 1/2. Add and subtract 1/2 to its x coordinate. So 3 minus 1/2 makes it 5 halves and negative 3/4. 3 plus 1/2, 7 halves and negative 3/4. That's how you find the endpoints. Is this easier than this one? I believe so, but that's ultimately your choice. So that's the synopsis of how we deal with parabolas using algebra we have seen before. And the same thing here, slightly different. That all you have to really remember is the relationship between the focal distance P and A when we go with this format. So those are the two. Identify the coordinates of the vertex. So again, just we have those 2 points, as I mentioned, the coordinates that was mentioned. Identify the coordinates of the vertex, the focus, the length of the lattice rectum, and the equation of the axis of symmetry and the directrix. Graph the parabola. You can always convert it to the format that we've seen in algebra and deal with it anyways. but you probably notice immediately the exponent 2 is on y, which makes it open sideways. Okay. Now, when you look at this clearly, the number next to x, meaning becomes -4, this becomes +2. That is the vertex, and that should be obvious. So it opens to the right. So it opens to the right, like so. Therefore, the axis of symmetry is this, y equals to. So that is -4, 2. Axis of symmetry is y2. So just right then and there, and again, just to give you an idea of what will help you figure everything out without making a mistake, it should look something like this. This is not to scale. The focus should be somewhere here, and the directrix must be a vertical line. So that's the information you should get from this. As soon as you recognize two things, location of a vertex and which way it opens. Okay. This is positive, by the way, forfeit. Remember, when that is positive, if you take it to the other side, it becomes positive also, and it means it opens to the right. So we have those information. So let me, so you expect the graph to look like that. You expect the focus to be on the right side of the vertex and the directrix on the left side, a vertical line. So that's what you should expect, and we're going to erase my work. And so 4p is 4/5. If you go with this and compare it to this one, 4/5 is 4p, and p is 1/5 or 0.2. Which means if I want to focus, okay, I'm going to use the p, which has the vertex, which has the coordinates -4, 2, and I'm going to use the p, which is 0.2, and I'm going to move this to the right. So I'm going to move this to the right, somewhere here, let's say. Again, this is not to scale. This is not the correct place. By how much? By p. So I'm going to add the p, or 0.2, to -4. And I get -3.82. Directrix is going to go back. So the x coordinate for the vertex is -4. I take it back by p. So x equals -4.2. Looking like that. Draw a parallel line to the directrix, and it crosses at these 2 points. Lattice rectum, the lattice rectum of a conic is this chord, and it's 4p. You remember that? And 4p was 4/5, or 0.8. So we go back to this point. The focus has the coordinates -3.8 and 2. So you go up and down, which means negative 3.8 doesn't change. 2 goes up by 2p, 2 times p, and goes down by 2 times p. So lattice rectum x is negative 3.8. What is y? You could put it into this equation and find it. I'm not going to do that. But an easier way, given the focus is at negative 3.8 comma 2. So x is negative 3.8 at plus minus 2p. Remember, this is 4p. So we add 2/5 or 0.4. So plus minus 0.4. So 2 plus 0.4 is 2.4. 2 minus 0.4 is 1.6. And those are the coordinates of those 2 points. So negative 3.8, 1.6, negative 3.8, 2.4. Those are the coordinates. Use the graph of a parabola to determine its equation in standard form. Let's see what's given. It's a parabola that opens down. You can think of it as x equals a y squared plus by plus c, or a times y minus k quantity squared plus h. Or think of it as x squared equals 4py, and therefore x minus h quantity squared is minus 4p times y minus k. That's your choice. Either one is fine. By the way, if you're more comfortable with this, you can go with that and then put it in the format that they ask you. Either way is fine. Clearly, we can see the vertex and the focus. The vertex and focus are located as follows: negative 3 comma 5, negative 3, 319 over 64. So far so good. We got a big part. Basically, we have h and k. All we have to do, because we have the vertex, find the focal distance, which we call p, and that is the distance between these 2 points, this distance. So what is the distance between these two? Is the distance between these two numbers, because they have the same x coordinates. So 5 is at top minus this number becomes 1 over 64, everybody. So now x minus h, that means x minus minus 3x plus 3 quantity squared equals minus 4p, minus 4 times 1 over 64, y minus k, y minus 5. And of course, this is negative 1 over 16, everybody. So that's the formula. And we are done. I just want to remind you of the other method that we have discussed. Y is a times x minus h quantity squared plus k. We have the vertex. So a times x minus minus 3 plus 3 quantity squared plus 5. So just following the fact that the vertex is given. The relationship between A and P is that one is 1/4 the other. And because it opens down, it's 1 over minus 4P in essence. Remember, if you go with the distance is always positive, okay? So you have to figure out the negative one way or another. So 1 over negative 4 times 1 over 64 gives you negative 16. And now you have the A, put it in, and you're done. Or just figure out the relationship that it's become 16 opens down, A must be negative. Somehow you have to account for the fact that it's negative. That's all. So very straightforward. Even the function expressed in standard form, f of x equals a times x minus h quantity squared plus k. This is the standard form that's used in many places. In some cases, they call this the vertex format. I want you to know that. And depending upon the terminology they use. And find the x-intercept, the y-intercept, the vertex, the axis of symmetry, graph the function. Well, in order to find the vertex, you have two choices. You can do completing the square as follows. Put these two together and take the two out. Complete the square, and that means b is 2 divided by 2 is 1. Squared is 1. So you are going to add 1, and it's important to understand when you add 1 inside, you're adding whatever this number is times that. So you're adding 2, you have a choice. Add 2 to the other side or add 2 and subtract same side. So this is x plus 1 squared. So 2 times x plus 1 squared. This positive 4. Therefore, the vertex located at negative 1 comma 4. A is a 2. It opens up. The x-intercept, we don't have any. How do we know that? If you calculate b squared minus 4ac, which is 4 squared minus 4 times 2 times 6, becomes negative. There is no x-intercept if there is no real solution, okay? Zeros or roots or x-intercepts in this case correspond to real solutions. And so x-intercepts, there is none. Y-intercept is 0, 6. Axis of symmetry, well, here's the vertex, so x equals negative 1. So when you graph the axis of symmetry, when you graph the vertex, let me put V here, vertex located at negative 1, positive 4. And we have the y-intercept at 0, 6, and it opens up by the symmetry because this distance is given as 1. If we go the same distance on the left side, we should get another point with the same y coordinate. So I hope you see that by symmetry, we can create one more point, and it just opens up like that. And there you have the graph. Very simple. This is just using the old method because that's what they're asking, and that's the method that they have presented the function. Identify the graph of each function. 10x squared plus 10y squared minus 100 equals 0. So when it comes to analytic geometry and various types of conics, we have a circle, we have an ellipse, we have a parabola, we have a hyperbola, which one is which, and we want to discuss that. And so the first one becomes a circle. Why is that? Both x squared and y squared are there with equal coefficients on the same side of the equation. Now, to prove it's a circle, you can put it in standard form. But instead of that, if you want to quickly come up with the answer, look at the exponent of x and the exponent of y. If both of them are degree 2, and they have equal coefficients, it doesn't matter what the coefficients are, as long as they're identical, that must be a circle. Part B must be an ellipse. Why is that? We have both x squared and y squared, but they have coefficients that are different. They have the same sign, however. So both x squared and y squared are there with different coefficients and the same sign on the same side of the equation. So if it's on the, if x squared and y squared are on the same side, and they have the same sign but different values, that is an ellipse. But this one, it's a hyperbola because if you bring them to the same side, they have different signs. So it's a hyperbola. Both x squared and y squared are there with coefficients that have different signs on the same side of the equation. So when you bring them to the same side, if they have different signs, that means one is positive, one is negative. Doesn't matter which one is which. It's a hyperbola. So I hope everybody's okay with this. Determine whether the graph opens up, down, left, or right. We are dealing with parabolas. Parabolas, there is only one quadratic variable, either x squared or y squared, not both. This one clearly opens down because a is negative. It is quadratic with respect to x, so it opens up or down. A is negative 2. Quadratic with respect to x, up or down, a is positive 1, so it's up. Quadratic with respect to y, it opens to the right or left. A is 1, therefore right. That's how you figure it out.